Pleased to welcome Kai Yu to the stage. Kai is the founder and CEO of Horizon Robotics. And Kai is going to talk about a new type of processor for the post-Moore's law era, where the nature of computing is changing from logic to artificial intelligence, and a revolution is happening at the edge. Kai?
So hello, everyone. It's my great pleasure to be here and sharing some of the story and the product by our company, Horizon Robotics. First of all, some general introduction to the company. For those of you who don't know Horizon Robotics, we are a startup in Beijing. Almost 3 years since the foundation. And today we have more than 500 regular full-time employees. The company emphasizes a lot on the very intensive technology innovation, so we apply a lot of patents. Last year, we launched the first ever AI ASIC, it's SoC actually, with the tape out at TSMC. A lot of investors, and the latest round of investment led by Intel with more than $100 million US. And we are closing a new round in next month. So we focus on the edge computing. So that means we don't care that much about the computation in the server or in the backend or data center. We want to push as much as possible the AI computation to the front end at the edge. So that means we care a lot about the low power consumption, low latency, real-time performance. And in terms of the application areas, primarily actually we focus on the two applications. In terms of the device, one is the camera, and the other one is the vehicles, the cars. And in terms of the cameras, actually the smart cameras, we believe it can be applied to many different application scenarios. But primarily we focus on the smart city and the smart retail. And for the vehicles, what we really excited about is the autonomous driving. But today, the large-scale deployment is still the ADAS. But I think the industry is moving for the ADAS, from ADAS to autonomous driving in the next 10 to 20 years. That's the most exciting probably opportunity for us and for many of you. So I think we are all talking about this paradigm shift of AI computing. So I have been working in actually Baidu for some years, since 2012. And when I established essentially the AI lab of Baidu, and then that actually was pretty much also a kind of pioneering work for the large-scale deployment of GPUs for deep learning training. But very soon we realized the training on GPU is fantastic. But then in the end of the day, we need to deploy the inference model. For example, for the CTR prediction for the online ads system. And that's a kind of massive computation, right? Because every day, the search engine needs to compute the neural network predictions for 1,000 billion predictions, and in real time, right? And the GPU cannot hold such a computation, right? Because for each query, we need to evaluate, 1,000 ads candidates, right? For each such a valuation, we compute the neural network inference, right? And the time delay is really critical, right? And that's actually eventually trigger the team to work on hardware acceleration, which is using FPGA for the online ads, neural network computation for the inference part. And that's actually the kind of my personal story about how I get into think about the hardware acceleration of the neural network computation. That was 2014. About 3 years ago, and I thought probably we should do, much further. Instead of using FPGA, why don't we, design dedicated hardware for the neural networks? So we were the first ever company in China, the commercial company funded to develop the AI processor in China, right? But a very interesting perspective about the company is the co-founders of Horizon Robotics, including myself, having very intensive software experience. I've been working on machine learning for 20 years, developing the algorithms. So fundamentally, I think the company today still putting a lot of resources working on software. So we have more than 100 expert researchers and engineers is working on innovating the foundation of AI, essentially from the perception all the way to decision making. So we think our mission is to developing the whole software stack for the generic robotics. Right, that's why actually we call the company Horizon Robotics. Essentially, we want to build up the horizontal software platform for the robotics, and we want to build up the horizontal hardware platform for the robotics. That's somehow, if you are curious about why we name the company this way, and essentially we want to build up the horizontal platform, including software and hardware for robotics. That means we actually work on a lot about, for example, what's the best decision-making software framework, right? To solve the problems, for example, like the trajectory planning for autonomous driving, right? And following that trajectory, and we are working on generation by generation the hardware design. So from the first generation is very perception-centric, right? And then followed by the second generation, this Bernoulli architecture, which is using very sparse neural network and fixed-point neural network, the computation, but for more powerful perception and more comprehensive understanding about the surrounding 3D structure and even the predictions of the movement of the objects and scene parsing. But our third generation, so-called Bayes architecture, is intended to, more powerful perception plus very powerful decision making, and even thinking about how to use the hardware to accelerate the computation, not neural networks, but this kind of, for example, Monte Carlo tree search, right? Today, when we talk about the AI hardware, I think probably 95% of the occasions, people only talk about the deep learning. But deep learning is not AI. Deep learning is just the part of AI, right? Deep learning is good for something, for example, perception, right? But for decision making, we need a different thing. For example, the Monte Carlo tree search or Bayesian network, causality reasoning type of things. So how to design the hardware to accelerate that kind of a more generic, broader scope of the AI computing, actually we should really think about that, right? So, and this is the first ASIC, the SoC. We taped out last year, which what we call Sunrise 1.0. So this is essentially a very low power processor based on our first generation architecture to empower the cameras, right? To make the cameras not just like a purely hardware, to make the cameras smart in a way that we can design different softwares to define a variety of functionalities to make the cameras can be applied in different scenarios, right? So why we want to push the computation to the front end, to the edge? If you make a comparison about the traditional architecture of the video surveillance or smart city, and today, which is kind of very popular in China, is you transmit all the videos back to the server side. And you pay very high cost for the bandwidth. And you pay very high cost to NVIDIA, right? And of course, the storage. And why don't we actually run all the video analytics on the edge in a camera, right? And then you don't need to send the original video data to the backend, but rather the structured output of the analytic result. And then much reduce the bandwidth. And then, of course, you don't run heavy computation in the backend. You save the cost. You don't buy that many GPU servers. And so in average, I think the deployment of the new type of architecture will save the deployment cost of hardware like by 10x. Well, here's some direct, give you some direct impression about the low power of the chip and yet the still high performance. And let me jump to the next one. Here, I give you a probably more intuitive, idea. So the upper one, this very bulky camera is made by the leading, camera vendor, Hikvision in China. They are amazing company. The market cap nowadays is like 400 billion RMB. And kind of a 60 billion US dollar company making cameras. And they use the NVIDIA TX1. This is very bulky because of the power consumption, right? And to the cooling is really a challenge, right? You can see the horrible machinery, for the cooling, right? And instead, we use a very small SoC. And the power consumption is only 1.5 watt. And then we don't need that cooling stuff. But then can make the cameras much smaller, right? And of course, much cheaper. But with much lower power consumption, right? For the typical scenarios, like in a dense crowd, for the face capture, tracking, and recognition. Simultaneously, we can process, 200 objects, but using a more powerful GPU in this case, about like 30 objects, and we can handle the computation for 1080p, 30 frames per second, and for the TX1 only 12 frames per second. So more powerful, but using much less, only 10% of the power consumption, right? And then here is some of the examples using the camera equipped with a Sunrise processor. This is the case of a busy morning. This is one of the subway station, Xizimen in Beijing, and this is in Forbidden City, kind of scanning dense crowd, faces, and we even run the face recognition locally inside of the camera. So we can have hold the database of 100,000 face of human IDs and run the computation completely locally. Because the processor has the software stack, the instruction set, and the compiler, and runtime library optimization. So we can use different software modules to run different tasks. So here's another case, which is the kind of traffic monitoring for a conjunction, intersection. You can see we use one single camera to cover 8 different lanes. Right, and all the cars, not only the car vehicle detection, but also the car model, right? Sedan or SUV or Volkswagen, and even the license plate, and we also do this kind of a pedestrian detection, right? Each different objects running a different model, detection model, right? This is very typical Beijing, right? And we really feel excited by the perspective. We can design different, just write different software functions and apply the same hardware in different application scenarios. In this case is the retail business. And in China, I think we are entering an area of using the technology to improve the efficiency of the offline retail. And in this case, what we are doing here is to digitalize, right, the customer behaviors in the physical environment. And their location, they move from one shelf to the next shelf, stay how much time there, how long there, and did they touch some products, right? That's really give you some insight about the data, and then help you to make a much better decisions, right? Imagine actually for Alibaba or for Amazon, you can track the whole data, right? I mean, a user from moving from one web page to the other, and how much time they spend there, and which hyperlink the user collected, right? The online business, they all collected this data, but the offline retail, they for a long time, they have no way to collect the data like that, right? And essentially, I think we are turning the physical retail store into something like a web page, right? So here is some a little bit more. Our another product line is the Journey processor. So the Sunrise processor is for the smart cameras, and Journey is for cars. Here is the Journey 2.0 processor. We're going to tape out by end of this year. So this is a multi-P architecture, and we designed the architecture in a way it's a multi-instruction and multi-data, and we can to make the instruction set very flexible. It can handle almost all kind of different neural network architectures. So even for the different kind of convolutional cores, we think about how to design the so-called elastic tensor core to make sure for different architecture they can all have a really high level of accelerations. So here I give you some direct impression about, for example, if we run the classical classification tasks, the image classification tasks on ImageNet, and compare the program optimized by the TensorRT on the TX2. And as you can see, actually, we test across a variety of different neural network models, from VGG to ResNet to MobileNet. And as you can see, a very interesting perspective is for the latest kind of more trendy neural networks. It looks like our Journey 2 actually has much bigger, advantage and more accelerations. And because we are essentially a software company, by the way, so we really know we have deeper understanding about software, and we know the trend, about how the neural network architecture will evolve, today and across, next 5 years. So somehow we design the neural network hardware, which is in favor of more trendy neural networks, right? And here's another comparison. And remember, this is only a 2 and 3 watt kind of low power processor. Even compared with like a Titan X, which is close to 300 watt. And if you run this like a pixel-wise segmentation on cityscape data, and we can achieve a much higher frame rate, higher accuracy, but using a tiny fraction of the power compared to Titan X. So we also offer very powerful and flexible open toolkits. You can accommodate like a Caffe, TensorFlow, MXNet. So one major perspective of the Journey 2 is for the acceleration for the pixel-wise segmentation. And if you make you have a, you get the sense about like the pixel-wise segmentation versus the traditional bounding box-based detection. Much more details, right? And here's the FPGA implementation of the Journey 2, and here's running like on a real vehicle. You can see the segmentation of the free space, and even the 3D coordinates of the vehicle is actually computed from the 2D video. And since this is California, so we show more cases on like this is the real-time processing of the 2D camera video mounted on cars on a Highway 280. And you can see we have really accurate, parsing about the free space, the cars, the 3D bounding box, the traffic signs. And here I think I have more videos on San Francisco downtown. It looks like playing a video game, but actually it's just real-time processing of we run a variety of different models, from the 3D bounding box, 2D bounding box, the segmentation, even the traffic sign, lamp pole, trees, pretty sophisticated computation. But we use only like less than 3 watt power consumption. Here's a very busy Chinatown for San Francisco. And here's the case, a project we work together with Audi, and to like a surround view pedestrian detection, the 360 degree surround view pedestrian. So let me finish by here, and I think we are developing the edge side, the edge computing AI processor for the smart cameras and smart cars. And that's it. Thank you.
And you finished right on time. Thanks, Kai. Comments or questions for Kai from the audience? Come on, all those people out there, somebody's got to have one.
Oh, hi, my name is Kwang. I'm from Canada. We start up companies in the healthcare areas. Even though it's just a startup company, therefore we don't have a lot of historical data. So we want to know what kind of company your company would be engaging in adapting using Sunrise or Journey to the future in order to build smart camera for the healthcare industry.
For the healthcare, yeah, I think actually for the application of smart cameras, actually we are engaging a surprisingly wide range of the use cases, covering the usual stuff like the security of city, but really some, for example, like a kindergarten, like even the coverage, the firing detection of the fires for the forest. That's all the use cases we've been touching now. And for the hospitals, not yet. But I hope I can talk with you, discuss with you, and what's the application scenarios. I think I remember some professors from Stanford. They are actually starting using the cameras to make sure like the procedures being properly followed by the doctors and nurses. That's probably one thing can be applied. Like if after some event, they if they wash hands already or not. So that's something. But I would love to talk to you offline. Yeah, thank you.
Next.
Yes, two questions. First, can you give us an idea how big the company is in terms of engineers and technical people?
So now we are having, and actually, in the beginning of the talk, I mentioned that we have like 500, and actually we are approaching 600 full-time employees, and now we have engineers close to 450.
Wow.
Right.
And secondly, where are you manufacturing your components?
TSMC.
Thank you.
Right. Thank you.
What process?
So for the Sunrise 1.0, it was actually 40 nanometers, and for the Journey, it's 28 nanometers. And there's one point I want to make here is if you look at like a purely hardware design, people are chasing really much more advanced the hardware procedure. But since we are actually a deeply integration of software and hardware, and we make the joint optimization, so we don't rely on the heavy investment on the hardware.
Well, I think
Right.
it's even more impressive that you're getting that kind of performance per watt in performance using 40 and 28 nanometer technologies. It'll be really exciting when you get to something like, 7 or 12. Or,
Right.
Okay.
Right.
Thank you.
Thanks.
Great questions. Any others? Maybe time for one more? Actually, I got one then. If we have time. You talked about in your earlier schedule slide, you showed for both FPGAs and ASICs, and then you
Right.
mentioned FPGAs later as well.
Right.
Do you anticipate that there are going to be some of your customers that go into production with FPGA-based designs, or is that just for emulation purposes?
For the Journey 2, right? So we are currently we demonstrated the FPGA boards for the on the vehicle for the segmentation kind of things. Actually impressed a lot of OEMs and the tier ones So currently we are offering the FPGA boards to some major well-established leading OEMs, global OEMs, and tier ones. Because currently, like using such a small, the board, the whole board is only 30 watt, but running this very sophisticated real-time computation. They found that actually currently in the industry there's no match, no close match. In terms of the functionality, it's much richer than mobile IQ4, but in terms of the power consumption, much lower than the NVIDIA driver PX2. And so we are offering the FPGA boards to our customers. And we're going to tape out this SoC based on this architecture in September. Okay. Right. So that means beginning of next year, we can offer our chips to our customers.
But obviously, the architecture maps pretty efficiently to an FPGA fabric if you're getting that kind of results.
Right. I think the SoC will be 2 to 3 times more powerful in terms of capacity than the FPGA. But in terms of the power consumption, it will be reduced by like an order of magnitude by 10. Right.
Okay.
Thank you.
Thank you very much.
Thank you.